Good morning, Geometry iPad Initiative students. This is Mr. Lane again, and we'll be discussing section 4.2, which is over angle relationships and triangles. So we're just building on our triangle knowledge again this section. We will be finding the measures of interior and exterior angles of a triangle, and we'll apply theorems to interior and exterior angles of a triangle. You can read through the why and make sure you answer number 5 in your notes along with your half a page and summary. Also, there is another secret word, so be paying attention for that. First one to email it to me. Remember, it's 2 points for you. So let's get moving. First thing we need to discuss, and it was in the first section also, but the sum of all 3 interior angles of a triangle will add to equal 180 degrees. So it doesn't matter which type of triangle it is, all the inside angles are always going to add to equal 180 degrees. Auxiliary line is a line that is added to a figure to aid in a proof. So if you have to add a line in somewhere for a proof, you may do so. It says, after an accident, the positions of a car are measured by the law enforcement to investigate the collision. Use a diagram below from the information collected to find the indicated angle measures. So we're supposed to find x, y, z, x, y, z. Well, in this particular triangle here, we are given 2 of the angle measures. So if we add those 2 together real quick, let's see, let's click on that. We'll have 102. Well, if there's 180 degrees in a triangle, then we can take that 180 degrees and subtract the 102 that we've already used, and it looks like we're going to have 78 degrees left over for this angle right up here. So that's 78 degrees. Alright, then we're supposed to find a YWZ, so this angle right down here. Well, we're given 12. Now this would be a linear pair right here, so they have to add up to equal 180. So if I took 180 and I subtracted 62 from it, then that looks like I'm going to get 118 left for this particular angle right in here. Now if I use 12 here and the 118, that's going to be 130. So out of the 180 left, this would be 50 degrees. Alright, let's move on here real quick. Regular geometry students would be doing problems 4, 5, and 15 from page 227. iPad class initiative students, always at the end of the lesson is your questions. I've got some definitions here. Corollary is a theorem whose proof shows directly from another theorem. So in other words, corollary is going to relate to some other theorem very closely. The first corollary we need to talk about is that acute angles of a right triangle are complementary. So if we draw a right triangle real quick, we can investigate this a little bit. Well, if this angle here is 90 degrees, then we have 90 degrees left for these other 2 angles, which would mean that they would have to add together to equal that 90 degrees. So that's what the corollary is saying. It says the measure of each angle of an equilateral triangle is 60 degrees, or equiangular triangle. Remember that an equiangular triangle is a triangle whose angle measures are all the same. So if all 3 of these are the same measure and they add up to equal 180, well, I'd take the 180 and divide it by 3, and that's definitely going to give me 60 degrees for each one of the angles. And that's what the corollary is saying, that if it's equiangular, they're all going to be 60 degrees. It would also work with equilateral. They're all going to be 60 degrees also. One of the acute angles in a right triangle's measures is 2x. What is the measure of the other acute angle? Well, remember that the two acute angles has to add together to equal 90. So if I had one, say it was 70 degrees, then the other one would have to be 20 degrees. So what I'm doing there is I'm just taking the one that I know and I'm subtracting it from 90 degrees to get the other one. So in other words, I'm going to have to take 90 degrees minus the 2x to actually equal the other angle. So I'm just going to slap the degrees on there and I'm done with this one. So regular geometry class students would be doing 6, 8, 16, and 18 from page 227. Geometry iPad initiative students, you guys always answer it at the end. Alright, interior of course means inside, exterior means outside. An interior angle is going to be formed by two sides of the triangle, and exterior angles may be formed from one side of a triangle and the extension of an adjacent side. So this here, with this number 3 down here, would be an exterior angle. The remote interior angles are going to be the angles that are not adjacent to the exterior angle that we're talking about. So if this is our exterior angle, this one would be adjacent here, the one that forms a linear pair. So the other two are going to be called the remote interior angles. So here I actually probably should have put that 1 and 2 are the remote interior angles for angle 3. So that's not quite worded right down here. Probably something I need to fix. So need to learn that vocab. There's going to be a theorem on it that we're going to use here shortly. It's right here actually, the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles, which means if I add together angles 1 and 2, that's going to equal angle 3. And that's what it says right there. Alright, so we've got to probably use this a little bit to find measure of angle B, which is right here. So we need to figure out how to use the remote interiors and the exterior to find x real quick. So if I know I add these together, it's got to equal this exterior one right out here. So I'm going to put 15 plus 2x plus 3 is going to equal 5x minus 60. So when I add the 15 and the 3 together, that's going to give me 18. I'm going to drop the 2x, and that's going to equal my 5x minus 60. So I need to bring the x's on the same side, so I'm going to subtract that 2x right over here from the 5x. This is going to give me 3x. I'm going to add the 60 over here to give me 78. Now I'm going to have to divide by the 3. So let's see, I'll go into 7 2 times, leave me an 18 left over, which is going to be a 6. So now I know what x is, but I still want to know the angle measure, so I need to plug in the 26 in for the x here. So 26 times 2 is going to be 52 plus 3 is going to be 55 degrees. So the actual answer for angle B is going to be 55 degrees. Here's the problems for the regular geometry class will be 9, 10, 20. Let's move on. Alright, the last theorem here is the third angle theorem. It says if two angles of one triangle are congruent to two angles of the other triangle, then the third pair of angles are congruent. Just makes sense. If I know two of them, then the last one's got to add to equal that 180 in both the two triangles, so the third angle is going to have to be the same. So we're supposed to use this information here to figure out the missing. So looks like two of the angles of the triangles are equal, so that means the third angles are going to have to be equal. So I'm going to have to set these two equal to each other. So I'm going to put 4y squared has to equal 6y squared minus 40. So I need to get the y's on the same side. I'm just going to go ahead and subtract the 6y squared over here. So that's going to be a negative 2y squared is going to equal the negative 40. So I'm going to go ahead and divide by the negative 2, just trying to isolate the I squared real quick. So that's going to be y squared equals 20. So now I need to take the square root of that, and I'm just going to put y equals the square root of 20 because that doesn't come out real even. Now I'm going to have to find each angle measure, so I'm going to have to plug out or plug in that radical 20 here. Well, remember that a squared and a radical undoes each other. So in other words, this squared and this square root are going to cancel each other out and just leave it at 20. So then you're going to have 20 times 4, making this angle 80. Well, by that theorem right above here, if k is 80, then j is going to have to be 80 degrees also, because they've got to be the same. Regular geometry students is going to do this. By the way, the secret word today, Avengers. Avengers. Alright, the up one, down ones are right there. Good luck on your boxes just for the fun of it. Oops, come on. Well, the boxes aren't clicking today, so we'll skip that. And this is Mr. Lane signing off from OHS High School. Catch you next time.